So we've heard this morning from the defense side, and of course, we've heard the demand signals there, but there are two sides to the same coin. And I am honored to present to you, how we can make commercial space launch a priority, a conversation on policy, regulations, and vision. And we have our AAA speakers here, Alex, Andrea, and Adam. Please welcome you to the stage. So, Professor Andrea Harrington currently serves as the co-director of the Institute of Air and Space Law and associate professor in the McGill Faculty of Law. Prof. Harrington previously served as the Dean of Space Education at the Air University for the United States Space Force. Alex MacDonald previously served as NASA's first chief economist. In this role, he helped establish NASA's Moon to Mars strategy and Artemis, and served as the program executive for the International Space Station National Laboratory. He was formerly the senior economic advisor in the Office of the Administration and the founding program executive of NASA's Emerging Space Office. Adam Trumpour is a rocket and gas turbine propulsion professional with a broad involvement in the industry. He is the founder and president of Launch Canada, an organization dedicated to supporting and advancing grassroots experimental rocketry in Canada, and runs the largest advanced rocket engineering competition in the country, as well as major collaborative technology development projects. So please help me welcome our three speakers to the stage. All right, so AAA panel, it's very exciting. We're going to talk about the commercial side of things, but just to kick it off, I would like to give you all just the first 1 to 2 minutes to maybe talk about your background, what sort of has led your career to this stage to work in space and policy and on the technical side as well, and what has led you here to this conference here today as well. So maybe Adam, I want to start with you.
All right, sure. So like you mentioned, I come at this from more of a technical background, and like General Horner, I was sort of captivated by rockets from a very early age. Unlike General Horner, I managed to avoid setting my neighbor's house on fire, but that love of rockets kind of never went away, and I sort of graduated from building model rockets to getting a couple engineering degrees in the subject of propulsion. And increasingly in Canada, for a very long time, we did not have a lot of outlets for people who gravitated towards that particular niche of space technology. So I took it upon myself to do it myself, and for about the last 20 years, I've been designing, building, and testing rocket engines. Starting about 12 years ago, we started to see this surge of interest in rocketry by university students. And so as somebody who had built up this skill set that was not very common, I worked increasingly to support and empower these students and help teach them how to not blow themselves up when doing this. And as I reached the limits of what I could do as one person in my spare time, I created Launch Canada to try to develop this talent in a more coordinated way, while also pushing for the sort of policy and regulatory changes that were necessary to enable this kind of experimental rocketry activity in Canada.
Thanks, Adam. Andrea?
Thank you very much. So like many of you here, I'm sure, I grew up as an enormous sci-fi nerd. So I'm not very good at math or engineering, so I didn't build the rockets, and thankfully that means I didn't light any neighbors' houses on fire. But I did get to see all of the inspirational Canadians and Canadian locations present in the science fiction that is so very famous, coming largely out of this country. Think what you will of Captain Kirk, but our first Starfleet captain in space was played by William Shatner, a Canadian, and looking to more recent sci-fi that we have had everything from my favorite book series, sorry Glenn, The Expanse, which starts with Leviathan Wakes, that was filmed here in Ontario, and of course there's the new version of Battlestar Galactica and Stargate Atlantis, which features its very own Canadian space scientist sporting his Canadian flag, and he's the reason that everyone in the world knows that here in Canada we say Z for the letter instead of Z. We also have the McGill Institute of Air and Space Law, which is where I now have the pleasure of teaching and directing our space law activities. I came to the McGill Institute of Air and Space Law originally to do a master's and a doctorate because it is the #1 place in the world to do air and space law. It's the oldest degree program in air and space law in the world, and I certainly would argue, and a lot of people would agree with me, still the best one out there. And of course, once I graduated from that program, though I went on to teach at other institutions and work with the US Space Force, anytime anybody asked me, what would your dream job be, where would you want to be, I said if I ever had the opportunity to be on the faculty at McGill and work in the Institute of Air and Space Law in Montreal, that's the place to be. And I was very, very lucky that I was able to get this position. And so here I am. The reason that we are so interested in the Institute of Air and Space Law in this conference that we have sponsored here today, and we've got a number of folks here today, is because we have the expertise in space governance. We understand how important it is, and we want to make sure that we are here to support industry and government here in Canada with this long history that we have at the IASL, and ensure that Canada is able to fulfill its role in the world within the within the space ecosystem. Thanks.
Thank you so much, Andrea. Alex?
Well, thank you, Derek, and thanks to Raul and the whole team organizing this, because I have to say I've been to a lot of space conferences in my time, and this is quite literally my favorite venue in the world. And I say that in part because I grew up in Ottawa, and I grew up coming here since I was probably not much older than 6. That particular Lancaster bomber has been one of my favorite objects in the world for quite some time. And I think we're going to probably have a lot more conferences here because as the Canadian space community grows, we need to remember the long heritage that we have and be inspired by what we can still build because we are going to have a proud and vibrant sovereign future in Canada. I got into space when I was a master's degree student at University of British Columbia in economics, and I saw the flight of Spaceship One, and I asked myself a very simple question, which is, did a bunch of people just build a spacecraft in a garage? If so, who funded it? And how long have we been seeing private funding of a similar type? That led to a PhD in economics. Back in 2005, very few people did space economics research, and so when I did that, I got a call from a Brigadier General down in the United States, Pete Warden, who some of you might be familiar with from the Wild Wild Space documentary, and he said, would you like to be my space economist? And I obviously said yes. So I moved to the United States, to NASA Ames Research Center, and worked with that whole crew, the team that then builds Planet and Astra and all that, and then went on my journey down to JPL and eventually to NASA headquarters to establish essentially the first office of the chief economist at NASA and help build the Artemis program. Because essentially what we now understand in the US, and I think we're starting to understand up here as well, is that space flight is an economic development problem as much as it is a technical problem. And it took a long time for us to really see that, I would say, but I think we're really starting to get our handle on that. And the reason that I'm here is because as a proud Canadian, I frankly think there is no more important issue than ensuring that the Canadian space community reaches its full potential, which despite our many achievements, we are very far from. And ensuring that we get orbital launch capability is, I think, an absolute priority for our community. So,
Awesome. Thank you, Alex. So why don't we dig into the topic of this panel here, and it really is a key topic of thought leadership for this conference today. And I'd like to split up our conversation into sort of 3 parts, the why we want to do it, and then the how, and the who, and the what, right? So for the why, and Alex, we'll keep it with you. So, in the last decade, we're certainly seeing a lot more, sort of startups or new companies go into space launch, and I think by 2030, there's projected to be over 20 nations who will have sovereign launch capabilities. And these are not just your traditional superpowers that you normally think of. These are countries such as New Zealand, Australia, Norway, Sweden, South Korea, Japan, and the list goes on. And we can very much see Canada as part of that list. So, given that there are so many other countries working on this already, so many companies as well working on this, why does Canada need commercial space launch? What are the benefits to Canada from economic, commercial, industrial, just population perspective? Like, why is it important?
As a reminder for my sins, I live in Washington, D.C., and so I'm going to be a little bit more direct than General Horner. There is an understanding that if there is ever another war between peer competitors or near peer competitors, that the first stages are very likely to be in space. Fundamentally, space access is foundational for 21st century space security. That's it. If we do not have our own assured access to space, then we are not going to be able to act in one of the most important domains of any potential future conflict. There is no guarantees. In the past, we could assume that we could buy space as a service, and we still do, very thankfully. And we want that to continue as long as possible. But that is not a guarantee. There are other benefits as well. Economic spin-offs from space are very significant. And as an economist, the way I try to explain that, it's not that it's about Tang and these types of things. It's about when you fund people to build complex space systems, they learn the most important types of engineering and technical skills that are needed for everything. And so when we fund orbital launch capabilities, we will be funding the critical technology skill set for the 21st century. Finally, I think it's quite clear at this point that we also need not just ambition, but clear signals of the success of an ambitious mindset in Canada. One of the great benefits, actually, of kind of, I would say, kind of limited understanding in some places of how complex or easy space launch is that I think people think space launch is very expensive in this country. It's too expensive for Canada. Well, that's actually a benefit, because you can actually achieve orbital launch at this point for $100 million. Multiple countries have done that. People think it's much more. So it'll be even more impressive to the country and to the world when we do it than it is now. If we want a strong signal of a sovereign Canada, there are few cheaper, strong signals, actually, than orbital launch.
Great, thanks, Alex. Andrea?
Thanks. So to start with, I'll kind of pick up where you left off in terms of signaling and say that one of the places that Canada is really strong for space is in diplomacy. Canada has very good diplomatic engagements, both bilateral, minilateral, and multilateral at the UN, including in the UN Committee on the Peaceful Uses of Outer Space. And in developing a Canadian national launch capability, that would further enable the levels of diplomatic engagement for Canada to model what a responsible power in space looks like going forward, growing from this point, and engage with other nations on that level, which of course enables cooperation and further economic growth and development for Canada. So there are government, economic, and social reasons to pursue Canadian space launch capabilities. Of course, Arctic sovereignty and national security in general are very important. Think of Earth observations, telecommunications, etc. In terms of those Earth observations, of course, climate change, climate data, weather monitoring, natural disaster monitoring and management are all critical for Canada with the enormous landmass here and all of the challenges that we face going forward in this time of climate change. And so these are important ways that we get access to space and are able to launch these important capabilities, in addition to, of course, the economic growth opportunities and the workforce retention and attraction that comes along with that, as my colleague already mentioned. Thanks.
Thanks, Andrea. Adam, would love to hear your thoughts.
So first of all, I could not agree more strongly with the points that my colleagues have made. I think at a very high level, in the world in which we find ourselves today, the cost to Canada, to its economy and to its national security of not having sovereign launch capabilities is too high. And I think this needs to change. And just to give one very concrete example of this, many times in the past, the Canadian government has unfortunately fallen victim to its lack of launch capability. Very famously, the RadarSat-2 spacecraft launched its ride to space when the United States government decided to block that launch. That led to years of delay and nearly $200 million in extra cost to the Canadian taxpayer. As Alex mentioned, that is roughly double what it cost SpaceX to develop their Falcon 1 launch vehicle. So just to put that number in perspective. So I think we have a real opportunity here to change this, but the cost of not having these capabilities cannot be downplayed either. And I think as well, you know, Canada has its foreign policy goals, and to be able to act on them, we have to have something to contribute. We have, for example, been a full-throated supporter of Ukraine for a number of years, but the reality is if we do not have the ability to provide the things that are required, then the Canadian government's freedom to act and achieve its foreign policy aims is going to be limited. I think this can change. This can change quite easily, and I think it needs to change.
Thanks so much, Adam. So we just covered the why. So why don't we move on to the how? And I think you've all touched on a bit of that as well. You know, of course, Canada in the past it has tried to do its own sovereign space launch, and that sort of involved importing, you know, vehicles from abroad as well. And nowadays we are seeing some upstarts as well, building their own capability on Canadian soil to launch from Canadian soil on a Canadian vehicle. So why don't we, you know, I'll start with Adam here and talk about the how. So, you know, what are in the context of acquiring or building launch in Canada, maybe tell us the pros and cons of each, and then also, you know, what do you see as the mechanisms to fund this, given that we sort of have this $100 million number? Not sure if that's USDs or CAD, but yeah, you want to dig into that?
All right, so big question there and a lot to unpack, but let's start at the very high level. So if you want to take on any sort of challenging problem, it's got to start with a very clear articulation of what the end goal is. What is it you are actually trying to achieve? Because how you define that is going to partly influence what the right strategy is to achieve that goal. Where we're at right now, I think, is we're seeing this growing understanding that, yeah, launch in kind of a nebulous sense is a general direction that we want to move towards, and we've begun to see, you know, different government agencies moving, broadly speaking, in that direction, but everything that's been happening so far has been quite disjointed and piecemeal, and there has never been a clearly articulated statement of what it is we're actually trying to achieve, what is the desired end state here. Once you have a desired end state in mind, and I would propose that the right end goal here is not just to procure a rocket for Canadian space missions. I think the right end goal is to create an entire ecosystem in the broadest sense that is amenable to all of the technologies that are required to make launch happen, as well as the infrastructure piece, the regulatory side, the procurement side. All of these things need to be a part of it. Once you've got the goal in mind, you then need to figure out what is the right strategy to get there. And until you actually have a strategy, a goal on its own is just a wish. Any strategy needs to look carefully at what are the resources we have, what is the most efficient and most effective way to deploy those resources, what are the resources we're going to need that we don't currently have, and how do we make sure they're available when they're needed. That needs to be the exercise in a broad sense. And I think it's a long conversation about what some of the ingredients of that need to be, but I think it's got to start with that top-level vision, ideally something that, you know, is clearly articulated by government and can then turn into line items on budgets and start marshaling the resources to work towards it.
Great, thanks, Adam. So, Andrea, what do you think from this perspective? How do we do it, like, officially be able to make this happen?
Yeah, so while of course the government procurement piece is going to be an important piece of it, the signaling, and that's part of what Adam was just talking about, from the government is incredibly important, because there are lots of investors out there who are looking to invest in space companies, but they need to have a feeling of comfort and a feeling of certainty that the government, through law, policy, and regulation, is going to be generally supportive of the kinds of technology, the kinds of efforts that are being put forward in order to make those investments. And so that signal of support from the government, it is incredibly important. And of course, there are rules that will need to be complied with, right? Environmental impact assessment, et cetera. And that's expected, but the understanding that these capabilities are something that are important to the government, and the government is willing to do what it takes to help companies understand the requirements, meet them, and be able to succeed, is what's going to get investment money brought into the Canadian space launch sector and the entire ecosystem surrounding that, including the relevant infrastructure, the relevant education and training programs, et cetera.
Great, thanks so much, Andrea. And Alex, since you're the economist, why don't we break up that $100 million number? Like, let's dig into it. How do we actually make it happen?
No, that's not what economists do.
Okay.
That's you need a grassroots engineering cost model for that, and I'm sure there's lots of people who can get into that. What we will get into is, why do we know that number? Well, we actually have a couple recent examples. You mentioned the SpaceX example. I prefer the Astra example. Took them $100 million, 5 years from founding to first orbital launch. One of the most recent ones. Similar for Rocket Lab. This is what it costs. So the key for me is actually, how do we just answer this question about what is the strategy? Because it's not that hard. We've done it at NASA, and actually it's basically the same strategy, frankly, that was used for Operation Warp Speed to develop the vaccines. And that strategy is as follows. It's basically 2 steps. First, you provide funding, essentially non-dilutive funding. Can be a grant, can be a contract, but it's an R&D type of funding that goes to companies, multiple companies that are pursuing multiple different technologies, because you don't quite know which technology is going to work or which company is ultimately going to be able to deliver this. And then you combine that with, it's called an advance market commitment, advance purchase commitment, to procure the services from those then developed capabilities. That's how we developed the capability to launch cargo to the International Space Station. We had the COTS program at NASA, and we gave $500 million to SpaceX, $500 million to Orbital Sciences. That was free money. And initially, we actually gave it to a different company, and when they weren't performing, we clawed back some of that money and re-awarded it. But we made sure that it was to 2 different companies, and this is really important for, I think, Canada to understand. Often we like to be very cost-effective. For those of us who are of Scottish descent, we might just say cheap. And so we say, well, let's just do one of these, right? We can't really afford 2. No, we can't afford to not have 2. Because if we want to actually achieve the policy objective of having an orbital launch capability that is domestic, there's no guarantees. So you need to give, I would say, $100 million Canadian. We can let the private sector market make up the difference, if there is one, to 2 different companies. And I would argue that that should probably come from D&D. I would love to have the CSA to have a budget of the size that would be able to support that, but I'm not sure that that's its best role right now. D&D has a $25 billion plus budget. There's no question that you could afford $100 million for 2 companies spread out over 5 years. Just a matter of policy priority. But the equally important part is a commitment to then buy the services from the organizations that would use launch, and that is where the CSA comes in. The CSA has, thankfully, a really successful program in CUBICS, the Canadian CubeSat Launch Initiative. There's no question that you could expand that as well. So there is demand for at least 5 to 10 launches of Canadian CubeSats that the CSA is already on the hook to be buying. Currently, they're buying from organizations like NanoRacks through the ISS. It's very good. But if you had contracts for somewhere between $10 to $15 million each, the CSA can afford that as well. So if you put those 2 pieces together, I would argue that that would be sufficient to incentivize the emergence of at least one and possibly actually two independent Canadian orbital capabilities. And we know this because we have done this exact same thing at NASA, in the US. It works. We just need to decide to do it.
Great, thanks so much, Alex. And I think to add to that point, we're obviously seeing the European Launcher Challenge as well, with really putting forth a significant amount of dollars that will make a difference, and they're again picking multiple winners as well, right? To develop that sovereign capability and make sure that it does stay there, and it's you create that competition as well. So within that, I think just the last point you did make there about the the procurement piece, the piece where after we develop this capability, we need people to actually buy, be a customer, right? And I think borrowing maybe from our defense side of things with like key industrial capabilities and the industrial and technological benefits program, of course that is meant more towards defense procurement, right? So what do we think from a space launch perspective? Because this is very much dual use purpose as well. Do we think there's any applicability here for things like Canadian content requirements for future sort of CubeSat or satellite launches from Canada?
I mean, that's an interesting question. I mean, I would say that ultimately, if you want a sovereign capability, you basically need to have it be as close to 100% capable as possible. I mean, it needs to be 100% Canadian content. Not always, but that needs to be the going assumption. I don't think you want to end up in a situation where we have a branch plant approach for space launch, because then you won't actually have a sovereign capability. So I think you need to be targeting the high-level goal of buying the services directly from Canadian companies. Now, we're not there yet, right? Right now, if we want to get our satellites to orbit, we want to still use SpaceX. Thankfully, we can still launch on them. We can still get CubeSats to the International Space Station. This is good. That's why I say you combine the stimulatory function of here is R&D money, here is $100 million of R&D money to two companies, with then saying, and when it is available, then we will be buying 6, 10 launches for CubeSats at the 250 to 500 kilogram capability level. There's no reason to constrain ourselves until that point, but having that top level objective of truly domestic orbital launch capabilities that are ITAR-free, ideally, I think is your starting point. I worry less about the kind of specific kind of Canadian procurement mechanism approaches than making sure that we understand that that is in fact the objective.
Great. Andrea, any thoughts on this?
Thanks. Yeah. So I think it's worth noting that the key industrial capabilities include specifically space systems and aerospace systems and components, but also other items on the list that directly contribute to these capabilities, like advanced materials, defense system integration, and training and simulation. So these are all areas that have this level of attention already, and space launch can fit right in there. I want to actually call attention to something else, though, that is available that might be of interest, and that is, of course, the grant funds available through the Tri-Agency, because this is another important thing to keep in mind. So different companies, different think tanks, organizations can partner with the fantastic academic institutions and institutes that we have here in Canada across the natural sciences, engineering, law and policy, et cetera, to work on these projects and get funding from the government through the Tri-Agency, whether it be SSHRC or whether it be natural sciences and engineering, and be able to move some of these projects forward with things like the New Frontiers in Research Fund and Insight grants that are out there. And that is a bit more open. That doesn't require any kind of defense-specific component, but does bring in many of the same types of technology, types of programs that are of interest in the key industrial capabilities list. And so depending on what exactly you're looking at, what kind of technology you're looking at, or what stage you're in, or what kind of project you want to solve, that's another option that is out there as well, as working with academic partners to obtain government grant funding for those projects there. Thanks.
Thanks. Adam, any thoughts?
Yeah, so one of the things that I think is really important to bear in mind when it comes to procurement is there are ways to go about procurements that are more effective and ways that are less effective. Very frequently, procurements by government tend to take this very top-down, very heavy-handed approach, where government dictates the requirements for the thing it wants, and then it will judge bidders based on their perceived ability to deliver that very specific thing. One of the things that the COTS program did, which was very good, so this was the Commercial Orbital Transportation Services that SpaceX and a number of companies used to develop the capability to deliver cargo to the International Space Station. They were a lot more flexible in how they approached this. So rather than it being NASA dictating detailed design requirements, it was more of a dialogue. And companies like SpaceX were able to actually challenge NASA's initial set of requirements. Case in point, SpaceX, when it bid for that contract, had in mind the Dragon spacecraft. They wanted to ultimately be able to carry astronauts on this. That is not a capability that would strictly be required for cargo delivery to the International Space Station, but because SpaceX had that as part of their own longer-term plan, they were able to propose a project that simultaneously gave NASA what it wanted, but also met SpaceX's other business and longer-term goals. The ability to do that is really, really critical. Very, very often, I think government does have this tendency, not just for procurements, but even for how it frames grant programs, to over-prescribe things. They tend to be very, very specific and carve very carefully defined boxes, and that is going to limit the kind of innovation that you can actually support. So it's important to be able to take a more flexible approach for these things.
And just to build on that, NASA was so flexible that not only did it basically only dictate at a very high level 1-2 pages of the requirements, right? X number of kilograms, this docking capability, you figure out how you want to do it. It also even said, and you tell us what are the technical milestones that we should then pay you at. It did not prescribe the procurement payment schedule. It said what is the appropriate procurement payment schedule for achieving this objective, and then evaluated the different proposers as to which they thought had the most effective one. It's a very different type of flexible approach.
Great, thank you so much. And we're just coming up at the end of our time here. So just to summarize, it does sound like, in order to make commercial space launch a priority in Canada, it's not just about the unit economics. It's not about Canada trying to find a cheaper way to space. There are other reasons why, like for sovereignty, for diplomatic positioning, for our position of Canada in the world, for our economy, for our jobs, and young people growing up and wanting to have something that's like inspirational for them to work on and work on really hard problems from the engineering perspective and be able to apply them to many other industries. So thank you so much, and please help me thank Alex, Andrea, and Adam on this panel.
Thanks so much.